Now in this lesson, we're going to talk about rules for small angle approximation. Okay, so in the previous lesson, we talked about small angle approximation, right? So when the angle or the value of x is sufficiently small, we can approximate sine x to be x, and then we can approximate cosine x to be roughly 1 minus x squared over 2 factorial, which I prefer to just leave it as 2. And then for tangent x, okay, it is approximately equals to x. All right, so I'm writing this down for reference. Okay, so we're going to take a look at two rules. All right, let's talk about rule number 1. Okay, rule 1 says that if x is sufficiently small, okay, I'm just going to write small over here, save some time. Okay, then 2x and 3x are also considered small. Okay, are considered small. So as a result of that, when you have when you're asked to approximate, let's say sine 2x instead, okay, then this is actually approximately equals to 2x as well. All right. Now in the previous lesson, we have used desmos.com/calculator, the online tool, okay, to illustrate these two graphs, right, sine x and x, and then we notice that when the values of x are close to 0, the two graphs actually coincide. All right, so I'm not going to repeat that over here, but you know, you can actually what I want to say is that you could repeat the exercise with these, and you realize that it's they are pretty close too. Likewise for sine 3x, okay, it is approximately equals to 3x. Now for this, okay, cosine, okay, as you can see for the pattern, we can cosine 2x, then it will be approximately equals to this, which is 1 minus, we'll replace the x with 2x, so that will give us 4x squared, right, which turns out to be minus 1 minus 2x squared, okay, so it's 4x squared divided by 2 is 2 minus 1 minus 2x squared. You can do likewise for this cosine 3x, okay, I'm not going to do so, and then finally the tangent 2x, okay, it will be 2x in this case, so on and so forth. All right, so that's rule number 1. Okay, so when x is sufficiently small, and we then consider 2x and 3x are also small, and therefore these are valid. Okay, now let's move on to rule 2. Okay, so rule 2 is this. Rule 2 is that x plus a, okay. Right, let's write this down. So again, we start off with if x is small or sufficiently small, okay, even though if a is sufficiently small, okay, x plus a is not considered small. All right, so this is how most of the notes would print it, okay? Of course, not word for word, but something to this context. It's a little bit weird, all right? I've got students asking me, well, I mean, if x is small and then a is small, maybe it's even smaller than x, all right? Okay, so if 2x is considered small, how is it that x plus a is not considered small? Now, the way I explain this is this, all right? Okay? The way I see it is this, all right? We will replicate what the notes say, okay? But I think it's easier to look at it from graph transformation. The thing is, when you have the graph, let's say for sine x, right? It goes this way, isn't it? Okay? But what happens is this: if you have a sine x plus a, okay? And suppose, I mean, it doesn't really matter whether a is positive or negative, but we know from graph transformation that when we have a, it actually shifts the graph either left or right, or rather translate the graph either left or right by a units. Okay, so if a happens to be positive, then we are going to translate the graph by a units in the negative x direction. So what happens is we'll be looking at the, you know, like a graph that looks like this. Okay, so this red dotted one is offset by a units. Okay, so that's the reason why, you know, the thing is, when you compare these two graphs, you know that this is never going to be a good approximation. Okay, so when they say it's not considered small, rather I would say that you know, there is kind of like a fixed error. So all the answers that you get is always offset, right? So for all the values here, regardless of how big or small your x values is. So I hope that makes sense. So usually I use this, okay, which is a translation okay, graph transformation to explain this, why this is never a good approximation if we were to consider sine x plus a is approximately equals to x plus a. It's not the case, okay? So what we'll do is that in this case, all right, when we were to work this out, sine x plus a, we will have to use identities, okay? We learned in our identities how to expand this, yes? Okay, so let me just erase this, all right? Now, back in secondary school, we already learned how to expand sine a plus b, which are all the compound angles, okay? The compound angles identities. So this will give us sine a, okay, so this is sine a cos b minus, plus cos a sine b, all right? So what you need to do when you have questions like that is to go ahead and expand this using your compound angle, okay? And most often, this a is actually going to be a known angle. So for example, a could be equal to pi over 2, or maybe a could be pi over 4, all right? So what you need to do is just go ahead and expand this, okay? So in this case, we have sine, right? Sine a, that will be just x, okay? Times cosine, right? So this small a, right? I will just change it to an angle. So we're going to use a big A over here, okay? Big A. And then after that, plus cosine x sine a, okay? Right? So these two values should be known, okay? Like I said, the a, okay, we switch it to capital A. Could be pi over 2, could be pi over 4. So we can evaluate that using our calculators. Or if you know the answer, just go ahead and evaluate them. And then as a result of that, when we take approximation, this is none other than just x cosine a, whatever this value is, the cosine a, plus bracket 1 minus x squared over 2, okay? And then after that, the sine a value. And then just go ahead and simplify it, okay? It works the same way. So I've got a space down here, so I'm going to erase this. Okay, it works the same way for the rest, all right? For, okay, so we have sine here. We're going to talk about cosine. It works the same way. So if you have cosine x plus a, okay, where a is also small, but remember this, okay, because of rule 2, we cannot, okay, replace the x plus a over here with the x plus a over here. We need to expand this again using a compound identities, all right? So for cosine, it's cos sine sine. So it's cos x cos a, okay, minus, right, sine x sine a. So you have all these identities in your MF26, your formula sheet. So just go ahead and refer them. Okay, now again, like I said, the a angle over here is a constant. It's usually given in the question. It's known. So if this is pi over 4, go ahead and figure out what this is. Go ahead and figure out what this is, okay? And then we can approximate that. So we have cosine x, which actually comes from here, and then the sine x, which comes from here. So all over again, it will look something like this. So x squared over 2, all right? And then after that, cosine a, whatever this actual value is, okay? And then after that, sine x will become x. Then the sine a, whatever, okay, multiplied with the actual value here, okay? Then again, you go ahead and simplify this if you can, all right? So make this into a nice expression in expanded form, okay? So lastly, tangent, all right? I think you get the idea by now. So again, tangent plus a, all right? Use your formula sheet and go ahead and expand this, okay, using a compound angle, right? So that will be tangent a, okay, which is tangent x, okay, I mean the first angle, not a, right? So tangent x plus tangent a, which is a known value, over 1 minus tangent x times tangent a, okay? Then you can go ahead and simplify this, okay, to go figure out what this is and this is. But if you were to use the small angle approximation, then this will reduce to x plus the known value of tangent a over 1 minus x times the known value of tangent a again. All right? So I did this small exercise over here for rule 2 just so that you have a stronger impression whenever you come across a question which involves a small angle x plus a fixed constant a. make sure you use compound angle to expand them, okay? And then after that, you will use the original approximation, okay, for the small angle approximation in the second line, okay? Here, here, here. Right? I hope that makes sense. So remember, rule 1 and rule number 2. That's it.